Nobody in the audiophile world wants to talk about home network. We'll debate interconnects for hours, agonize over rack placement, spend weeks choosing a DAC, and then plug a $3,000 music streamer into the same router our kids use to play video games and forget about it entirely. Here's the reality. High-res audio files are large, and streaming them continuously requires a stable, consistent flow of data. Your home network isn't built for that. It was built for tolerance, to handle a dozen devices, all fighting for bandwidth at once, dropping and requesting packets constantly. Your streamer has a buffer, yes, but on a congested network, that buffer runs dry. And when it does, you get dropouts. You get streaming service quietly stepping your 24-bit high-res file down to a lower quality tier to keep up. And you get the frustrating experience of a system that never quite behaves the way it should. If you've ever sat down to listen and spend the first 10 minutes troubleshooting instead of restarting your router, requeuing a track, or wondering why Rune lost its connection again, that's not bad luck. That's a network problem. And if you don't fix the foundation, no upgrade you make to your system above it will ever fix that. I had a long conversation about this with Mike Gibbs. And if you want the unfiltered version, we recorded a full episode of the Fidelity Exchange, our podcast with Mike, that I'll link at the end of the video. Mike is a network architect with 25 years of experience, building the backbone infrastructure for major internet service providers. He's also the founder of Go Cloud Careers, a platform that helps IT professionals develop enterprise networking skills at the highest level. That background gives him a perspective on home networking problems that you generally don't find anywhere else in the audiophile space. At Moon Audio, we've always run commercial-grade Cisco Meraki equipment, not because we're gear snobs about it, but because in a professional audio environment, reliability isn't optional. I can't have a customer's listening session interrupted because the office network decided to update something in the background. So I already understood the value of a Sirius network. What Mike helped me understood was why Sirius, by enterprise standards, and Sirius for high-res audio are actually two different things. But isn't digital data just ones and zeros? Now, I know what the skeptics are thinking because Mike was one of them. As a career data engineer, his instinct was that the bits either arrive or they don't, and modern networks are good enough that they always arrive. And technically, he's not wrong. The data itself isn't degrading. What degrades is the experience of getting that data reliably, at a volume, over time, on a network that's also handling everything else in your house simultaneously. When Mike finally sat down and listened to a properly isolated audio network running through a pair of Focal Utopias with our Silver Dragon premium headphone cable, his reaction was the same one I've seen from a lot of technically minded people. Quite surprised. Not because the bits were suddenly different, but because the system was finally free to do its job without fighting the infrastructure. That's what we're after. Not magic, just a network that actually supports what you're asking it to do. Here's my advice. Number 1, wire your streamer. No exceptions. The first thing you need to do is run an Ethernet cable from your router or switch directly to your streamer. Wi-Fi is a shared environment. Every device in range is competing for the same airspace, and the protocol that governs it is built around managing collisions. When two devices try to transmit at the same moment, they both stop. Wait a random interval and try again. That behavior is invisible and inconsequential when you're loading a web page or sending an email. For high-res audio stream that needs to sustain a continuous, uninterrupted flow of data, often at 24,192 or higher, that unpredictability is a real liability. The other thing worth understanding about Wi-Fi is that it's a shared medium in a way Ethernet simply isn't. Every device connected to your wireless network can hear every other device's transmissions, and the more devices you have, the worse the congestion gets. A busy household with a smart home device, phones, laptops, and streaming TVs all in the same wireless network is generally a hostile environment for a high-res audio system. That needs consistent, sustained bandwidth. Once you commit to a wired connection, the cable itself matters. For most people, a quality shielded Cat7 or Cat8 cable is the right answer. Shielding prevents crosstalk, which is what happens when the electrical signals from individual wires inside the cable start to interfere with each other. It's a subtle problem and an easy one to overlook, but we've seen it cause real difficult to diagnose issues in a customer's install. The cable becomes a noise source. Spending a few extra extra dollars on shielded cable upfront eliminates that variable entirely. For listeners who want to take the connection to the next level, we make our own Dragon Network cables here at Moon Audio. We offer the Bronze Dragon Network cable starting at $250 and the Silver Dragon Network cable starting at $400. Both are built specifically for audiophile applications, designed to reduce noise and preserve signal integrity throughout the entire network chain, from your router to your switch to your streaming device. And because we make them to order, you get exactly the length you need rather than dealing with the excess slack that comes with off-the-shelf cables. That matters because coiled or bundled excess cable creates its own interference problems that's a properly measured run avoid entirely. If you've already invested in resolving system, your Ethernet connection is no place to compromise on cable quality. And regardless of which cable you use, pay attention to how you route it. Running Ethernet cable parallel to power cables over a long distance invites interference. Cross them at right angles if you have to. Don't run them side by side. There are small decisions, but in a system that's been carefully optimized, everything else matters. They're the kind of details that hold everything together. Here's my advice number 2. Give your audio gear its own lane. Even after you wire your streamer, it's still sharing a network with everything else in the house. And everything else is noisy, not loud, not obvious, just constantly present. Smart TVs push firmware updates at 2 in the morning. Security cameras stream continuous video to local storage. Smart home hubs pull their devices on a regular cycle. Your laptop syncs files to the cloud the moment it wakes up. None of these things are misbehaving. They're doing exactly what they're designed to do. The problem is they're all doing it at the same network your root nucleus is trying to stream a high-resolution file across. And your router has to manage all that traffic simultaneously. When the network is under load, something has to give, and too often it's your audio stream. The simplest solution is a 2-switch setup, and it doesn't require any advanced networking knowledge to implement. You buy 2 switches. They don't need to be expensive at this stage, and you divide your devices between them. One switch handles everything general purpose, TVs, computers, smart home gear, and gaming consoles. The other switch handles your audio equipment, your root nucleus, your NAS, your streamer, anything else in the listening room that's part of the music chain. You run a single clean connection from the main router to the audio switch. What you've created is a physical separation the noise of your household networks and other devices will stay off of. The audio switch isn't fighting for attention. It's receiving a single managed feed and distributing it only to equipment that benefits from a clean signal path. Beyond the 2-switch setup, there are 2 additional moves worth knowing about. The first is asking your ISP to put their gateway into bridge mode. Most IP provider routers are handling for more jobs than they were built for. They're simultaneously acting as a modem, a router, a firewall, and a wireless access point, all with limited processing resources. Under a heavy load, they become a bottleneck, and often a noisy one. Putting the ISP gateway into bridge mode turns it into a simple pass-through and lets you use your own router, one you've chosen, one that's properly resourced for the size of your network, handles all the network interaction. It's a meaningful upgrade to the overall stability of your setup, and it costs nothing beyond the conversation with your ISP. The second, for those of you who want to go further, is VLAN configuration. A VLAN is a virtual local area network. It lets you use a single physical network infrastructure while creating logical separate segments within it. You can configure a dedicated VLAN for your audio devices and assign it a traffic priority so that even when the network is under load, your music stream is just first in line. This does require a managed switch and some router level configuration, and it's generally more involved than the 2-switch approach. But if you have a Synology NAS, a Unify, or a Meraki setup, or any router with VLAN support, it's well within reach. And for a listener who wants the maximum possible separation between their audio chain and the rest of their household traffic, it's the right approach. I'll be honest, VLAN setup is one of those things that's easier to watch than to read about. I've spent time with a channel on YouTube called Crosstalk Solutions. They have a video called VLANs Made Easy. That's 41 minutes long and generally one of the clearest technical walkthroughs I've found for this specific topic. I'll link it in the description below. It's the resource I'd hand to anyone who wants to do this properly rather than guess their way through it. Here's my advice number 3, the hardware ladder, matching your switch to your system. Once your network topology is right and everything is wired and your audio gear is on its own dedicated path, the next conversation is the hardware itself. And this is where audiophile grade switches come in. Not as a magic box, not as an audiophile mythology, but as purpose-built tools that address the specific electrical and timing demands of high-resolution audio environments in ways that a standard IT piece of equipment simply isn't designed to do. The question I get most often is, why not just buy a commercial Cisco or Netgear switch? And the honest answer is that you can, but you're trading one problem for another. Commercial enterprise switches are exceptional at what they were designed for, moving data reliably at a scale in IT environments. But they were designed for server rooms and office deployments, not listening rooms. They run switching power supplies that generate high-frequency noise, they're cooled with fans that add mechanical vibration to the environment, and they need a network engineer to configure them for anything beyond basic use. Audiophile switches are the opposite. Plug and play by design, passively cooled, and built from the ground up with clean linear power supplies, not to mention the precision clocks. We have 3 options we recommend, and where you land on this ladder should match where your system is. The iFi OmniLAN at $799 is the right starting point for most people, making their first move into dedicated audio networking hardware. Its standout feature is triple-stage optical isolation. The incoming signal is converted from electrical to light inside the chassis. This is completely severing the connection between input and output before being regenerated by active circuitry, which goes well beyond the standard galvanized isolation it can do. A femtosecond precision GMT clock that reclocks the regenerated signal to eliminate jitter. The iFi OmniLAN at $799 is the right starting point for most people making their first move into dedicated audio networking hardware. Its standout feature is a triple-stage optical isolation. The incoming signal is converted from electrical to light inside the chassis, completely severing the connection between input and output before being regenerated by active circuitry, which goes well beyond what standard galvanic isolation can do. A femtosecond precision GMT clock that then reclocks the regenerated signal to eliminate jitter. And 13 ports give you plenty of flexibility. 4 ultra-pure outputs for the critical audio devices, 9 standard ports for everything else. It's plug-and-play, passively cooled, and managed via the iFi Nexus app from your listening chair. For a listener who has sorted their wiring and network topology and wants to address the quality of the signal itself, the OmniLAN is an excellent place to start. If you're running a more resolving system and want to step up your precision of your network timing, the Matrix Audio SS1 Pro at $1799 is where that conversation gets serious. Matrix Audio built it around a counterintuitive but sound engineering principle. A circuit designed for higher speed transmission is inherently more stable, so the SS1 Pro runs at 2.5 gigabits per second, far beyond what audio requires, specifically because that headroom buys you lower timing error at normal operating speeds. If you have devices that operate at 10G, then there are 2 SFP ports. The power supply is a custom O-core toroidal transformer feeding ultra-low noise linear regulators, and the clock is a femtosecond precision reference with an RF synthesizer for phase noise performance that matches the ambition of the rest of the design. The chassis is precision machined aluminum, passively cooled, and the port LEDs can be switched off entirely for late night listening. For a listener whose DAC and streamer are already performing at a high level and who wants their network infrastructure to match that investment, the SS1 Pro is the right step. And at the reference level, the Orander NH10 at $4,300 is the benchmark. It's built around an OCXO all-in-one oven-controlled crystal oscillator with frequency stability rated at less than 0.005 parts per million, a level of clock precision that Orander synchronizes to every port via FPGA control. So the entire hub operates from a single master timing reference. The power supply is purely linear throughout, no switching regulators, no DC to DC converters anywhere in the circuit, and every port combines advanced filtering with optical galvanized isolation that uses light to transmit data, creating a complete electrical barrier between your audio equipment and the rest of the network. The precision machined aluminum chassis weighs nearly 18 pounds, and that mass isn't for aesthetics. It's actively dampening the micro vibrations that would otherwise affect clock stability in a sensitive system. If you have a world-class system, this is the infrastructure it was built to run on. Remember, your signal chain starts at the wall, and that includes the network. A system that was expensive to build deserves infrastructure that's actually up to the job. None of what we covered today requires you to become a network engineer. A wired connection, a dedicated switch for your audio gear, and the right hardware for your system level, those 3 steps will get you to the place where your streaming setup is reliable. Your high-res files play at full resolution. You're spending your listening time actually listening instead of troubleshooting. If you want to go much deeper on this, and I mean significantly deeper, Mike and I recorded a full episode of Fidelity Exchange where we get into the real technical weeds. How IP multicast affects streaming behavior, why 10 gigabit network links matter even for audio, and exactly why the gateway your ISP installed might be the single weakest point in your entire system. It's one of the most technically substantive conversations we've had on the podcast. And if this video got you thinking, that episode is the right natural next step. I'll link it right here and see you at the next one.